Good morning, dear student. Today, once again, we are going to our online classes. Today, we will discuss about how to make dimension formula of any physical quantity and what is the use of dimension formula. So, first of all, dimension formula of any physical quantity which defined the relation between derived quantity to the fundamental quantity and its units. Its general expression, suppose we have any physical quantity represented by x, so its general formula m to the power a or any variable terms, l to the power b and t to the power c, where m stand mass, L stand length and T stand time, and A is the dimension of mass, B is the dimension of length and C is the dimension of T. These are integer numbers. So look here, how can we form dimension formula of any physical quantity? So first of all, we find out what is the unit of that physical quantity. For example, velocity. So we know that velocity is equal to displacement upon time. Displacement, its SI unit is meter and time, its SI unit is second. So now what is the dimension formula? So dimension formula of velocity we can write there. First of all, mass. Since velocity does not depend on the mass of any body, and here no unit of mass, so we can write here mass m and its power is 0. Meter is the SI unit of length, so we can write their length, but here meter comes out one time, so we apply here 1. Second is the SI unit of time, but it is inversely and it comes one time, so we can write minus 1. So this one is the dimension formula of velocity. So dear student, we see here that velocity only depends on the length and time. It does not depend on the mass of any body. Similarly, we have another physical quantity, acceleration. Acceleration is equal to change in velocity. It means velocity upon time. So guys, velocity, what is the SI unit of velocity? Velocity and its SI unit meter per second. So we can write meter per second, and time again here and its SI unit second. So we can write meter per second square or also meter into second to the power minus 2. So we can write there its SI dimension formula mass. Here no SI unit of mass, so m to the power 0. Meter is the SI unit of length and it comes one time, So we can write L to the power 1 time. It's SI unit second and it comes 2 time but inversely. So we can write here minus 2. So dimension formula of acceleration m0 L1 t minus 2. Similarly, force. Force is equal to mass into acceleration. Mass. Its SI unit kg. Acceleration here mass per second square, or also we can write kg into meter into second to the power minus 2. So its dimension formula, first of all, mass, its SI unit kg, and look here guys, here kg comes one time, so we can write here m to the power 1, m which stand meter and it is SI unit of length, so we can write here L to the power 1. Second comes 2 time but inversely, so we can write minus 2. So dimension formula of force m1 L1 t minus 2. We can easily see that force which is depend on the mass, it also depend on the length and also depend on the time. So there are so many examples and we can form easily dimension formula of these physical quantities.